Hello, I'm Jeremy and I'm a product specialist at Abstract. In this video, we're going to look at how we can import a file that uses X-Rite's Appearance Exchange format, also known as AXF, and import it directly into InstaMAT Studio to generate a dynamic PBR material that we can easily make adjustments to and reuse in future projects. Let's dive in. Alright, so here we are in InstaMAT Studio, and the first thing I'm going to do is create a new element graph. So I'm going to go to New Project and choose Element Graph and create project without a template. And so this is going to bring us into InstaMAT's node-based UI, which we call the canvas. So I'm going to name this project. I'm going to call it Leather. And so next what we need to do is import our Axf file. And we can do this by importing it into our InstaMAT package or link the file with a path. In this case, I'm going to import it into the package. This keeps all of your related files together and makes it easy to transfer and share projects with other people. So I'm just going to go off screen and drag the Axf file into the package management panel here. You can see it's under my assets, and there it is. So now what I'm going to do is I'm going to drag the Axf file into the graph. You can see it becomes a node here. And then next off, I'm going to drag a connection off of that node, let go to bring up quick search, and I'm going to type in AXF to get the AXF material node. I can go ahead and click that. You can see we now have our material, and that's all you need to access the information inside of the AXF file. I can go ahead and right click the node and choose to preview as 3D material. You can see our viewport appears here, and we can now see our leather material created from that AXF file. And so with this AXF material node, we can access all the different material maps and information inside of the file. And we can now use that information just like we were dealing with a PBR material like the ones that come built into InstaMAT's material library. Now, if we click on the AXF material node, you can see that we have all these different controls for the AXF to PBR conversion that's happening here. But there's one setting that I want to adjust, which is this scale. And so I'd like to make it so that I can apply this material very easily across a larger surface area. So I'm just going to go to the scale and increase it from 1 to about 3. And you can see what it's done here. It's tiled the material a bit more so that we can see what this looks like much more easily on a larger surface area. So now let's continue the process of creating a dynamic PBR material by setting up some of our material maps. So to do this, what I'm going to do is I'm going to use quick search to bring in a node called Material Make. And the reason why I like this node is because it gives us all of the inputs that we need to create a PBR material. So what I'm going to do is right click the Material Make node and choose Preview as 3D Material to view its outputs in our viewport so we can see what we're doing as we go along. And I'm going to connect the base color, normal, roughness, and metalness information to the Material Make. And so now this should look just like before when we were viewing the outputs of the AXF material node, but now we're viewing the outputs of the Material Make node. Now, you might have noticed that there are a few inputs left on our Material Make node, notably the Height and Ambient Occlusion maps. Now, if we look at our AXF data, you can see that we do have a height output here, but if I click on that, you can see there isn't any height information present. We can click on these output pins to view our maps in the image viewer, but as you can see for height, we don't have any height data. The same thing is for ambient occlusion. We actually don't even have an ambient occlusion output here. Now, luckily, InstaMAT can generate this missing information using the data that we already have. So let's start by creating our height map. Now I'm going to hold the Command or Control key and press the right arrow key, and that's just going to move over all the nodes that I have to the right of my cursor. And so what I'm going to do is I'm going to branch a connection off of the normal output of our AXF material node and let go to bring up quick search, and I'm going to type in normal to height. If I go ahead and hit enter, this brings in the normal to height node. And what this does is create a height map from our normal information from the AXF data. You can see we get this beautiful height map that we can use for our material. So if I go ahead, let's go ahead and preview this. I'll go ahead and connect the output of our height to the Material Make node here. And you can see what it's done. It's now displacing and pushing out the geometry that the material is set on. This is really great and adds lots of depth to the material. And so let's make some adjustments to our viewport here. I'm going to go ahead and click this 3D cube. It's going to switch our view. So now the viewport is the center area here. And I'm going to go to the gear to go to our viewport settings. And let's just make some adjustments. I'm going to go to the bottom where the render settings are. And I'm just going to increase my tessellation level to 24. And you can also see that we have this displacement factor. I just want to verify that I have this set to 1. And now I also want to change the mesh that we're viewing our material on. And because this is a leather, I want to make sure this looks good on some kind of cloth-like surface. So I'll go to the 3D cube here, and I'm going to choose a different mesh. And now InstaMAT has a bunch of different meshes to choose from that come built in. I'm going to use this cloth sphere. And so now I can see what this looks like a lot better on a cloth-like surface using that cloth sphere. So let's switch back to the view we were at before. I'll click this button to bring the canvas in the center, and we'll use the 3D cube up here to see our cloth sphere on the left. So I'm noticing as I zoom in here that we're getting a lot of displacement, a lot of extra push on the vertices here. And so I need to even out the height map a little bit. And so to do that, I'm going to go to the normal to height node and adjust this height range parameter. So what we can do is, you can see I'm getting a preview of the height map in the image viewer here. If I just increase this, we can bump up the dark parts of the map a little bit. And in fact, I'm just going to bump this up a little bit to somewhere around 0.2. You can hold the command or control keys to snap to 0.1 increments. And then I'm also going to bring this down as well. We're just flattening out the map, and you can actually see what's going on in the 3D viewport. We're just evening out this height map so that it's much more of a smoother surface. And I think I'll choose somewhere around 0.6. Looking pretty nice. So I think that looks a little more realistic. You still get a little bit of that displacement where we're pushing out from the surface, but not so much so that it looks a bit unnatural. Now, having a height map not only gives our material that nice effect where we can displace the surface of the mesh that it's on, but it also gives us some additional information that we can use to further enhance our material, such as the information we need for an ambient occlusion map. So let's create an ambient occlusion map now as well, and we can do that now that we have our height data. So I'm just going to drag another connection here from the normal to height and let go. And I'm going to type in height 2 and then the map that I need, which is ambient occlusion. You can actually see it's already there because Quick Search has predicted what we need to do. But I can again type in ambient occlusion and hit enter. And now we have the height to ambient occlusion node. And so I'll go ahead and connect this to the ambient occlusion input of the material make. And now you can see we have a little bit more definition. It's added those contact shadows within the crevices of the leather to give us a little more definition and clarity of our material. And so this is great. You can see that InstaMAT has been able to utilize the height information that it has generated from our Axf File's normal data to further generate our ambient occlusion map. Now, both our height and ambient occlusion maps are useful for later on as well, where we're going to add some natural looking effects to our material like dirt and dust. But before we do that, I want to make this material a bit more dynamic. I want to add some more dynamic functionality to our material by making it possible to easily change the color of our leather by using InstaMAT's Color Picker widget. So to do that, I'm going to right click to bring up Quick Search, and I'm going to bring in the Color Match node. Now, the Color Match node makes it possible to adjust the colors of an input image, in this case, that being our base color, so that it matches a target color. So I'm going to take the base color output from our Axf material, plug it into the input here. Let's go ahead and view the output in our image viewer by pressing the green output pin here, or you can press V on the keyboard to view the output. And you can see actually there's some interesting information here. We've got not only the main color, but also we have these spots. If I click on the original source, you can see that we have these spots that are picked up from the Axf data, and that's important later on. So I'll go ahead and click that output. We can see what's going on. And now I can adjust my target color, but let's go ahead and quickly connect this to the base color of our material make node so we can see this in the 3D view as well. And now I can change the target color to effectively change the color of the leather. But you'll notice something interesting here. You notice that I'm picking a bright pink color in the target color, but we're getting a darker, more muted color. And we can fix this with these Luma settings as a part of the Color Match node. So if I do something like decrease the Luma variation, we're getting much more closer to our target color. And you can see we're still getting a little bit of those dark patches from the leather. It might be more difficult to see with YouTube's compression. What you can do is just adjust this luma variation. So if we increase it, we're going to see those a bit more, but the whole overall color is going to get a bit darker. But if we decrease this to somewhere around, let's say 0.3, and now you see we're getting a much more accurate result from the color that we picked. And that's kind of the response that I want from this parameter. When I pick a color from the color picker, I want the resulting color to match as closely as it can to the color that I picked. So now I'm going to do is go ahead and pick the color that I want for my leather. So I'll go ahead and choose something like perhaps this dark brown color, and now it's going to appear on my material. But now there's one more thing that we have to do to make this more accessible, and that is we need to expose this target color parameter. And this will make it possible to adjust the target color from outside of our graph. And we can do that in other InstaMAT projects as well as in InstaMAT's integrations. So to expose the target color, I'm going to right click and choose Expose as Input Parameter. You can see we now have this node here. And if I click on the graph, you can see we have our target color graph input. I can rename this. We can call this leather color. And so now I can change this color from many different places, whether it's from the root level of the graph or from within another graph if we instance this material, or in other InstaMAT projects, or like I mentioned before, in InstaMAT's integrations. So I'm going to change this color. I've got the, if I click on this, I can bring up the larger color palette. I've got a preset color here, which is this light tan color, and I think that's looking pretty nice. Now, next up, what I want to do is make it possible to add some dirt and grunge to our material to make it appear more worn. And we can do this easily with a material effect dirt node. So I'm going to go and move over here, and the material effect nodes are great because we can take our materials and easily add natural looking effects to them. So I'm going to right click to bring up quick search and type in material effect dirt and go ahead and bring that in. Now here's something really cool. Now what we can do is we could connect all these pins to the material effect dirt node. However, because we have a lot of pins to work with here, it's going to get quite taxing to do this all manually. So what we can do is go to the link up here, this link button, and this is link category mode. So if I click this, it's going to combine all the related pins together into one connection. And so now I can go ahead and drag this singular connection to the material input. And if I untoggle this, you can see it's connected all of those connections for us. So that's really handy. So I'll right click this and view the outputs of the dirt node. And you can now see that the dirt node has filled in these crevices with a natural looking dirt effect. And that's because we have that height and ambient occlusion information that we're able to do this. So what I'd like to do is I'm going to increase the dirt level, and you might notice that the dirt isn't really having that much effect. And so what I like to do in this case is I like to adjust the ambient occlusion intensity and variance. So if you notice, if I decrease the variance, for example, it's going to fill in more of those cracks. And if I increase the intensity, it's going to make the dirt much more intense as we increase this dirt level. So in this case, I'm going to dial this in just a little bit. I think what I'll do is I'll set the intensity to somewhere around maybe, let's say 43%. I think that looks pretty good there. And maybe I'll also adjust the variance as well. I think that looks pretty good there as well too. And now if I increase the dirt level, we get much more of a prominent effect if we need it. But we also have a really cool option here, which is the grunge. So if I increase this as well, we can add some natural looking grunge patches onto the surface of our material, which is really nice. And I can adjust the scale here. So I'll set this to somewhere around, I think 1 to have bigger patches based on the scale of this material. And so now if I adjust the dirt level, you can see we can add those on or subtract them off to get a nice clean surface or a much more grungy, dirty leather surface. So what I want to do is I want to make this dirt parameter exposed to the user to outside of this graph. So I'll go ahead and right click the dirt level and choose Expose as Input Parameter. Now next, let's do the same thing, but add some dust as well. So instead of using quick search, I'm going to branch off a connection from the dirt node. And this time you can see that quick search recognizes that we're working with a lot of material information, and it's suggesting the effects that we have here. So I'm just going to find the material effect dust node and double click that to bring it in. And again, I'm going to right click and view this as view our outputs so that we can view it in the 3D viewport. And let me go ahead and dial down that dirt just a little bit as well. I think it's a little too much for this case. And let's go back to the dust. And so if I go ahead and increase this, you can see it's a very subtle effect. You can see you actually see it in the lighting. It's much more reflective and shiny, but as soon as the dust settles on the surface, it's going to make it a little more rough. So this is a really nice effect to have. You can see this also has a grunge setting as well. So let's go ahead and make sure we expose this dust effect to the user as well. So I'll right click the dust level and choose expose as input parameter. So now we have our dirt and dust settings here that we can easily dial in and change the color of our material too. Now there's one last node that I'd like to add to the end here, and that is the Material Finalize node. So I'm going to branch off another connection from the dust node here to bring up quick search, and I'm going to type in final. So I'll go ahead and bring that in. Now, the Material Finalize node has a bunch of really useful features that really tie the whole material together at the end. So for example, you can see here we have this base color AO darkening. Let's go ahead and preview everything as we do it. So I'll go ahead and right click and preview as 3D material. And so this node has some subtle but powerful effects that really tie this material together to take it from 95% all the way to 100. So for example, you can see that there's this base color AO darkening. So we add a little bit of the ambient occlusion information into the base color to give it some nice extra definition. You can also see that we have some sharpening as well. So you can increase the sharpening based on the perceived distance of this material. So if it's a bit further away, you know it's not going to be seen up close, you can increase the sharpening to really make this pop. Now, the Material Finalize node also has some useful parameters that you can expose to the user. So for example, what we could do is we could expose the normal strength. So I'll go ahead and right click and choose expose as input parameter because it's useful to be able to adjust the normal strength whenever you need to. You can also expose the height blur parameter as well. And this is helpful if when we're displacing the geometry using the height map, for example, if you're getting some jagged edges, you can slightly blur the height map and you don't need to do that very much. You can see that the default here is 5% and that's all we really need here. And you can also see that we have the hue, saturation, and luminosity settings here as well. So we can easily adjust those parameters and you can expose them if you want to be able to control the color of your material that way. So now that we have the Material Finalize node done, let's go ahead and do the last thing here, which is expose our material outputs. Now, these outputs are going to signify what information is being exported out of our graph. Now, it's really easy to create these outputs due to the fact that we're already using nodes that have all of these material connections built in. So if I turn off link category mode here, you can see that we have the base color, normal, roughness, AO, and height already available. So all I have to do is right click on the node here and choose to expose output parameters. And so I'm going to go ahead and select all, and because we don't have an emissive map here, I'm just going to disable that one and choose expose. And now InstaMAT has exposed and created all of our material outputs for us. So let's go ahead and do a quick recap of what we've covered. So I'm going to go back to the beginning, and the first thing that we did was we dragged in the Axf file into the graph to represent it as a node. And we then used the Axf material node to convert the Axf data to that PBR information. And so it helped us by giving us the base color, normal, and roughness maps that we needed. But what we needed to do was generate some additional maps because some of that information was not included in the Axf data. And that included things like the height map and the ambient occlusion map. So we could convert the provided normal information from the Axf file and create a height map from that data. And then we could use that height information to create our ambient occlusion information as well. And then we had all of the input maps that we needed to create a PBR material, and we used the material make node to combine those all together. We then wanted to make our material more dynamic, and so we took advantage of the color match node so that we can easily change the color of our leather. And we can do that by exposing the target color parameter and by using this color widget. We then added some material effects that add some natural looking dirt and dust. And we could do that because we generated the height and ambient occlusion data for our material. We then used the Material Finalize node to bring everything together and also make it so that we can expose some really useful parameters like adjusting the normal strength and blurring the height. Finally, we exposed all of our outputs so we then have all the maps that we need when we export this material. Now, if you'd like to export this material out as images, what you can do is go to the curved arrow here. This is the Export Image and Data Outputs window. So if I click that, you can see that we have this nice, really comprehensive dialog that allows us to create any kind of export template and configuration that we want to export our maps out. So you can supply an output path here. You can create a naming convention format and use some variables if you want to. And you can also choose specifically the format settings for the maps that you're exporting. So you can go ahead and choose to export these maps at 4K if you'd like to, or maybe if you want to lower resolution textures, you can lower it to 1K. And we also have a selection of templates available as well. Now you can create your own templates. We also have some built-in templates as well, for example, with Unreal Engine. And so I don't want to make this video too long, and we can have a dedicated video for the output dialog, but I also want to mention that you can do channel packing and conversions as well. So you can see here for the Unreal Engine template, we're actually combining the ambient occlusion, roughness, and metalness together into the red, green, and blue channels of this one map that's being exported. So it's very, very powerful. And when you'd like to export your images, all you have to do is go down and choose Export. Thanks for watching this video where we focused on how we can import an Axf file into InstaMAT Studio, convert it to PBR material information, and add dynamic parameters so that we can make quick adjustments to our material on the fly. The Axf material node is just one of the many powerful nodes built into InstaMAT. And if you'd like to learn more about the other nodes and project types in InstaMAT Studio, be sure to subscribe to our YouTube channel. Here you can find an ever-expanding library of videos covering the ins and outs of InstaMAT. Well, that's it for now. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaMAT, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.